Okay, so hi, today we're going to be solving some problems related to identifying elements, isotopes, and ions, depending on the number of protons, neutrons, and electrons given. Okay, so let's take a look at 5 different types of problems. Okay, so the first type of problem is this. How many protons and electrons are present in an argon atom? Okay, in this case, basically what it's saying is we need to identify the number of protons and electrons given a type of atom. Okay, now the atomic number Z conceptually is the number of protons, and it's the defining concept of an element. It defines what the element's identity is. So in this case, what we need to do is find argon in the periodic table and then look at the number on the top left corner. Okay, so argon is right here, the top left corner is 18, which means the number of protons in an argon atom is 18. There are 18 protons in an argon atom. Now, because this atom is electrically neutral, meaning the charge is 0, there are the same number of protons and 18 electrons are present in the argon atom. The second type of problem is this. What is the name of the element that has an atom that contains 82 protons? Similar to this one, we need to find which box has 82 on the upper left corner, and then we look at the name of that element. Okay, so that's the second type of problem. Let's take a look at our periodic table. 82 protons, that means we have to look for a box which says 82 on the top, and that's right here, Pb. So Pb is the symbol for the element which is lead. So the element that we're looking for is lead, okay? So the answer to this problem would be lead. The name of the element that has atoms that contain 82 protons is lead, and the symbol is Pb, okay? The third type of problem is this. Let's take a look. Write the chemical symbol for the ion with 74 protons and 68 electrons. Okay, so in this case, there are two things that we need to consider. First of all, what is the identity of the element? And second of all, what's the charge? Okay, so first of all, what is the identity of the element? That is actually revealed by the protons, right? Because like I said, the atomic number is a specific quality for each element. Okay, so first, like we always do, we go back to our periodic table and we look for where 74 is. 74 is right here, tungsten, W. Okay, so tungsten is the identity of the element. Tungsten is the element with 74 protons. You cannot change that. That's just something that's set. Tungsten is the only one and only element that can have 74 protons. Okay, but it can have different charges. Okay, so if we go quickly up here, notice that the number of protons and electrons may differ in an atom. Okay, for any atom that has the same number of protons and electrons, it's electrically neutral, okay? It's just an atom. But if it has different numbers, then it's an ion. If there's more protons, it's a cation. If there's less protons than electrons, it's an anion. So in this case, which one would it be? It's a cation, right? Because there's more protons. That's basically saying that there are 74 positive charges, but 68 negative charges. You can see that it doesn't balance out, and there's actually more positive charges. So what we do in this case is essentially just add these two together. 74 minus 68 is what? 6, right? 6 plus. So that means there's actually a net positive 6 charge. So this would be the correct chemical symbol, okay? Let's take a look at the fourth type of problem. How many protons, neutrons, and electrons are present in the zirconium ion? Okay, so that looks a little bit complex, but if we dissect it one by one, the number on the upper left corner is what's known as the mass number. Okay, the mass number represents the sum of the protons and the neutrons. Okay, so that's basically what it is. The number on the bottom is the atomic number. Okay, the number on the bottom represents how many protons there are. So at this point, one thing should be obvious. How do we determine the number of neutrons? Basically, we just subtract the atomic number from the mass number, okay? So that's pretty intuitive. We just do 91 minus 40. Okay, in this case, 91 minus 40 is 51. So we know how many protons there are. That's just given by the atomic number. There are 40 protons. How many neutrons are there? That's just 51. And electrons, like I said before, the electrons and protons are determined by how much charge difference there is, okay? So we know there's 40 protons, there's 40 positive. There's some amount of negative electrons such that their sum is 4 plus, it's still 4 positive. So 40 minus x is 4, x, the question is, x is 36, right? X is 36. So there are 36 electrons. There's a deficiency of electrons, which means there's more protons, okay? Now the last problem is a bit more complex, but essentially it's a reverse engineering of this one. So let's take a look. Write the complete chemical symbol for the ion with 27 protons, 32 neutrons, and 25 electrons. Okay, so like always, we take a look at the protons first and notice that that is a quantity that determines the identity of the element. So 27 protons right here, cobalt. Okay, so 27 protons always means that it's going to be cobalt no matter what. Okay, and then like this, we write the atomic number on the bottom. The mass number is the sum of these two. Okay, that's 59. 27 plus 32 is 59, so we write 59 up here. And this charge number we actually determine by comparing these two, right? There's 27 plus positive and there's 25 negative, which means the net positive charge is 2. So we write 2 plus, and this over here is going to be our final answer. I hope that was clear, and thank you for watching. That's just how you solve problems related to electrons, neutrons, protons in identifying elements. Okay, so the key point is that protons determines the identity of the element, mass number, proton plus neutron, and charge determined by proton and electron. Okay, thanks.